So let's take a look at perpendicular lines and their slopes. If we look at the diagram over here, we have a couple lines that are perpendicular. And first of all, we can tell that they don't have the same slope, right? In fact, they are pretty different. This line, line HG, has a positive slope. It's moving upwards as I move from left to right along the line. The other line, EF, has a negative slope. It's moving downwards as I go from left to right along that line. So we can already tell that the lines will not have the same slope. But let's see if there is some kind of relationship between their slopes. So the first thing I'm going to do is I'm going to calculate the slope of each of these lines. So let's start with the slope of, let's do the slope of line HG first. So my slope of line HG, well, I need to know what the coordinates of a couple points on line HG are. So we'll look at H here, which is at, let's see here, if I want to figure out what its coordinate is, I'm going to go with the origin. I'm going to go left 1, 2, 3, 4, 5, and then down 1, 2, 3, 4. So I went left 5 and down 4. That gives it a coordinate of -5, -4. Now if I look at G, from the origin, G goes to the right, 1, 2, 3, 4, and then up, 1, 2, 3, 4, 5, 6, 7, 8. So right 4 and up 8 gives G a coordinate of 4, 8. So now let's figure out its slope. I'm going to take the two y coordinates and subtract them. So I'll do 8 minus -4. And then in the denominator of my fraction, I'm going to take the two x coordinates and subtract them. 4 minus -5. So this is going to turn out to be 8 plus 4 on the top and 4 plus 5 on the bottom. So we have a slope of 12 over 9, which if I reduce that, I'm going to keep it as an improper fraction. I'm not going to turn it into a mixed number. I'm going to keep it as an improper fraction. Divide top and bottom by 3. Divide that by 3. Divide that by 3. And I'm going to get 4/3 for the slope of line HG. So I'm just going to write that along the side here. Slope is positive 4/3. That makes sense. It's positive, like we talked about. It's going up. So now let's talk about the coordinates for E and G so that we can find the slope of line EG. So point E is at -3, positive 2, 4, 6, 7. -3, 7 would be the coordinates of E. -3, 7. And F is at 1, 2, 3, 4, 5, 1. So that is at 5, 1. So now let's find the slope of line EF. Again, I'm going to do the y coordinates first. I'm going to say 7 minus 1, and then I'll do the x coordinates, -3 minus 5. Simplifying this gives me a numerator of 6 and a denominator of -8. So now if I can divide both of these by 2, then I'll have, first of all, I notice that my numerator is positive and my denominator is negative. So that means my overall fraction is going to be negative. I'm going to move the negative sign. Instead of putting it down in the denominator, I'm going to put it off to the side of my fraction. My numerator is going to be 3 and my denominator is 4. So now my slope is -3/4. So now let's investigate the relationship between those two slopes. We already noticed that one's positive and one's negative like we expected, but then if you look at the actual numbers involved in the slope, this one's 4/3, this one's 3/4. In math, we call that being reciprocals of one another. We just kind of took the fraction and we flipped it over. So the slopes of two perpendicular lines, what this tells us is the slope of two perpendicular lines will always be opposite reciprocals. And when we say opposite reciprocals, we mean we're going to change the sign and we're going to flip the fraction over. So if one line has a slope of -2, then the perpendicular line would have a slope of positive 1/2. Your textbook this year deals with slopes of perpendicular lines a little bit differently, and I'm going to kind of put their definition down here. What they say is perpendicular lines perpendicular lines have slopes with a product of -1. And so that works too. If I look at those two slopes, 4/3 and -3/4, if I was to take 4/3 and multiply it by -3/4, then I would have a positive times a negative, so I know my answer is going to be negative. When I multiply fractions, I just multiply numerators and then multiply denominators. So 4 times 3 is going to be 12 in the numerator, 3 times 4 will be 12 in the denominator, and I know since I have 12 over 12, that really turns into -1. So just to kind of show you how that idea works. These two things are basically saying the same thing. If the two slopes are opposite reciprocals, that means that when I multiply them together, I'll have an answer of -1. So you can think of that either way you would like. So now let's take a look at a couple examples using this idea. Again, I have a diagram here with a lot of different lines going on, and we're supposed to decide whether certain lines in this picture are perpendicular to each other. So I have, starting off with line J and line K. So we're going to do the same thing we did when we were looking at parallel lines. We are going to first identify some points on each of these lines that we can use to determine their slope. So if I look at line J, I want to look on line J and find a point like right here, where it's easy to figure out what the coordinates of that point would be. It rests right on the intersection of two of the grid lines. And then I want to find another one, so I keep traveling up the line, and then I see another point right there. So I'll put a point there. I'm not going to label these just to keep my graph or my diagram is already pretty messy, so I'm going to just kind of keep the labels off of here. Now I want to figure out what is the slope. Using these 2 points, let's think about rise over run and figure out what the slope is. So if I move from this point to this point, I already noticed that as I go to the left, I'm moving down. So I know that my slope of line J should be a negative slope. And then I think, okay, I move down 1, 2, 3, and then over 2. So the slope of J's slope is -3 over 2. Then what about K's slope? Well, we got to find a couple points on K. I'm going to label a couple points that I think show the line going through the grid lines on my graph. So I got a couple there. I notice that this one is positive slope because it's going upwards as it moves from left to right. So now I'm just going to do rise over run. To get from here to here, I go up 2 and then to the right 3. So for K, my slope is 2 over 3. And now if I take a look at these slopes, I notice that one's negative and one's positive, and they're reciprocals of one another, 3 over 2 compared to 2 over 3. So therefore, yes, J is perpendicular to K because their slopes are opposite reciprocals. Or if we looked at it and I multiplied those together, they would have a product of -1. That would be another way to look at it. Okay, so let's take a look at H and L. Let's figure out what their slopes are and decide if they're perpendicular or not. So for line H, I'm going to label a couple points. I see this point here on H, and then it looks like I see this point right here on H. For L, I see a point right here, and then as I travel down, I have this same point right here. So for line H, it's got a negative slope that goes down 2 and to the right 3. So my slope for H is down 2 and right 3, or it's -2/3. Now for L, my slope goes, as I'm moving from, this will be a positive slope because it's going up. It's going to go up 1, 2, 3, 4, 5, and then right 2. So my slope is up 5, right 2, so it's 5/2. Now if I look at these two slopes, one is negative and one is positive, but they're not reciprocals. So they're opposite signs, but they're not reciprocals. Therefore, I can say that H is not parallel to L because slopes are not opposite reciprocals.